In this video, we're going to be looking at compound interest. So words to remember in this lesson is the word compound interest here. That is the interest that is earned on both the principal and any interest that has been earned previously. And of course, this compound interest formula, which is represented by this formula. A is equal to P multiplied by 1 plus R raised to T, where A represents the amount of money in the account at the end of the time period, P is the principal, R is the annual interest rate, and T is the time in years. Balance. So the sum of the principal and the interest, that's how you call it, balance. Let's look at some examples in here. Jackie deposits $325 in an account that pays 4.1% interest compounded annually. How much money will Jackie have in her account after 3 years? So in here we can see that the 325 is our principal, 4.1 is our interest, and it says that compounded annually. Okay, and our T in here is going to be 3 years. So let's put that together in our formula. So our formula for compound interest is going to be A P1 plus rate raised to T. So our principal is 325 multiplied by 1 plus, this is our rate. In decimal form, that's going to give you 0.041 raised to 3 years. So putting into your calculator, this is going to give you 366.63. Call it 636, but I'm going to round it off to 2 decimal places. That's gonna give you 366.64. Okay, so at the end of 3 years, this is now going to be the amount of Jackie's account. Okay, so let's try this. Find the amount in an account after 2 years using the compound interest formula. So our principal in here is this one. That's gonna give you 285. 1 plus this is going to be in decimal form is going to be 0.019. 0.019, and this is going to be 6 years raised to 6. If we're going to multiply all of this, this is going to give you 319.07. Okay, so that's the answer to that. Next in here, the principal in here is going to be 1,200. And this is going to be in decimal form, is going to be 0.087. So 0.087 raised to 2. So this is going to give you around 1,417 and 88 cents. Okay, that's the answer to these two simple problems. So with regards to the compounding periods, I would like you to be very, very familiar with these compounding periods. Okay, so let's look at them slowly. So when you say compounded annually, that's mean once a year, the number of compounding is only 1. So when you say semi-annually, that's going to be twice a year. The compounding period N is equal to 2. When you say quarterly, that's going to be 4 times a year, and it's represented by the number 4. Bi-monthly, it means every month, that's going to be 6. Monthly, it's going to be 12 times a year, and it's going to be represented by 12 as the number of years. Semi-monthly, it means twice a month, that's going to give you 24. Bi-weekly, okay, every 2 weeks, you have 26. Weekly, it means once a week, that's gonna be 52. And of course, daily, it means once a day, it's gonna give you 365 days. Now, the very most common compounding periods that's being used is actually once a year, semi-annually, quarterly, bi-monthly, sometimes monthly, and in some other cases, you can also use all of these other compounding periods. So now that I have discussed with you about the compounding periods, what I would like to show you now is the formulas for compound interest with its compounding period. So if you're going to be looking at this part, this one, okay, you can see in there that this A is equal to P1 plus R. This N now is going to be the compounding period multiplied by the compounding period plus the time. Okay, so remember that your compounding period can be 1, can be 2, can be 4, and so on. Okay, so the other thing that I would like to teach you in here is the continuous compounding. The continuous compounding is represented by this formula, the principal, and your Euler's constant raised to the rate and the time multiplied together. So we're going to look at these two formulas for compound interest shortly. So here is an example of what I have discussed earlier. So a total of 12,000 is invested at an annual interest rate of 9%. Find the balance after 5 years if it is compounded quarterly. So in here, quarterly, the compounding period is going to be 4. Monthly is equal to 12. And this is going to be the last compound interest that I have shown you earlier. So let's first do the letter A. Okay, A is equal to P1 plus the rate divided by its compounding period raised to NT. So here our P is 12,000, then multiplied by 1 plus our rate is 9%, which is going to give you 0.09 divided by the compounding period, which is 4. Then divided by 4 times, how many years do we have? 5 years. We have 5 years in there. So that's going to be 4 times 5. So if you're going to compute all of this using a calculator, this is going to give you 18,726.11. Okay, so that is the amount after 5 years compounded quarterly. Okay, now let's look at letter B. Okay, for letter B, it says that it is going to be compounded monthly. So letter B, A is going to be 12,000 still. 12,000 multiplied by 1 plus 0.09. Since it is monthly, it's going to be 12. That's going to be 12 times 5. So we're going to use our calculator in here. Okay, so this is going to give you 18,788.17. Okay, so that is the amount if it is compounded monthly. So let's look at letter C this time. Letter C, it says that it's compounded continuously. Our formula for compounded continuously is A is equal to P, the Euler's formula, raised to R, and its time. Okay, so let's fill up everything. This is going to give you 12,000, that's the principal. And you're going to use E raised to our rate is going to be 0.09. Then we're going to multiply that with 5 years, right? Okay, so I would like you to use your calculator and find the E. It's going to be looking at this way in your calculator. Okay, then you're going to compute everything. So this is going to give you a total of 18,819.7746, but I'm just going to close it to two decimal places. So that means this is just around 18,000 819.75. Okay, so this is how you easily compute compounding continuously. Okay, more compound interest problems. In this example, let's look at our P. If you deposit 4,000, so that's going to be your P, and then into an account paying 6%, the rate is 6%, so that's around 0.06 in decimal. Annual interest, the compounding period is quarterly, means it's gonna be 4. And how much money will be in the amount after 5 years? T is equal to 5. Okay, so A is equal to P1 plus rate divided by compounding period, and T, our P in here is going to be 4,000 multiplied by 1 plus 0.06 all over 4 raised to 4 times 5. Okay, so putting that all in your calculator, this should give you an amount of 5,387.42. Okay, that's it. In this next example, we're going to look at the situation. If you deposit 6,500 into an account paying 8% annual interest compounded monthly, here, compounding period is 12. How much money will be in the account after 7 years? So in here, our T is 7 years, and our rate is going to be 8%, and that's going to be 0.08. And of course, our principal is going to be 6,500. Okay, so let's compute it. At the end of 7 years, here we go, we're going to say 6,500 multiplied by 1 plus 0.08 all over 12 multiplied by 12 times 7. So if you're going to put all of this in your calculator, this should give you around 11,358 and 24 cents. Okay, so let's look at this next problem. How much money would you need to deposit today at 9% annual interest compounded monthly to have 12,000 in the account after 6 years? So they are asking us something very important in here. It says, how much money would you need to deposit? That means that we are asked to look at the principal. So principal, we don't know, but we are given the rate. The rate is going to be 9% or simply 0.09 in decimals. Our T here is going to be 6 years, and our final balance is going to be 12,000. Okay, so let's look at it. Let's put that into our equation. So A is equal to P1 plus R over N raised to NT. Okay, it says here compounded monthly. Our compounding period here is going to be 12. Okay, so our amount of A here is 12,000 divided by P, which is we do not know. But in here, we know that it's going to be 1 plus 0.09 divided by the compounding period, which is 12 times 12 multiplied by 6. So the very first thing we're going to do is to simplify the this part. Okay, we're going to simplify this part first. So if you're going to simplify that in your calculators, this is going to give you around 1.098. Let me just write the whole number, 721671. Here it's going to be still the same 12,000. Now we're going to be dividing both sides with this 1.098721671, 1.098721671. We cancel this out. So what is left now in here is going to be, the principal is going to be this one. So if you're going to be using your calculator in here, this should give you around 10,921 and 78. But if you're going to close it to a whole number, that's going to give you 10,922. Okay, that's very nice. More compound interest problems. If you deposit 5,000 into an account paying 6% annual interest compounded monthly, how long until there is 8,000 in the account? So in here, we are given the deposit, which is going to be our principal, which is 5,000. The rate is 6%. Compounded monthly, which is 12. And this is going to be our final amount, which is 8,000. But there is something missing in here. And if you're going to be looking at that, actually says how long. It means they're looking for the time. Okay, so let's put that in our equation right now. So we have A is equal to P1 plus R over N multiplied by NT. So our A here is 8,000. Our P is 5,000 multiplied by 1 plus our annual interest is 6%. That's going to give you 0.06 divided by compounded monthly, and is equal to 12. That's going to be 12. And here 12 multiplied by t. We don't know the time. So our goal in here is to find the time. So the very first thing we're going to do is to simplify this using our calculator. So that's going to give you 8,000 here, 5,000. And if we're going to put this in our calculator, this is going to give you 1.005 raised to 12t. Then we're going to divide both sides with 5,000, 5,000. So this is going to be just 1. Let's remove that 1. So what is left in here is only 8 over 5 is equal to 1.005 raised to 12t. Since we are finding the time in here, then we needed the help of logarithms. So let's put this both sides with logarithms and logarithms. So what is left in here now is going to give you logarithms of 8 over 5. And in here is going to be the logarithms of 1.005 raised to 12t. Solving for the time, we're going to put this in front. So that's going to give you logarithms of 8 over 5 divided by 12t multiplied by the logarithms of 1.005, and we're going to divide both sides with logarithms of 1.005, logarithms of 1.005. We cancel this out. What is left is 1. So what is left on this side is just going to be 12t and then this one. So let's just write it down for clarity's sake. 8 over 5. Then we're going to divide that by the logarithm of 1.005. Now put this in into your calculator. So therefore, once you compute that, it should give you around 94 point, I will just write the whole number, okay? 23, 55, 32, and 32. Since we're going to be finding t in here, we have to divide both sides again by 12 to isolate t in here. And t now is going to be giving you 7 point here, 7.852. Okay, so if we're going to put this into its final answer, this is going to be the year already. So that's going to give you 7 years. Okay, and if I'm going to multiply this one with 12, then I can get the number of months. So that's going to give you around 10 months. Okay, so that is the answer. So let's try to look at the question at the top. Says how long until there is 8,000. So with all of this computation, we can now answer and say that it will take 7 years and 10 months. Okay, so this is the answer to the question above. For this next problem, it's almost identical with the first one. So let's look at it. If you deposit 8,000 into an account paying 7% annual interest compounded quarterly, how long until there is 12,400 in the account? So first, let's look at what is given to us. 8,000 is our principal, 7% is our rate, compounded quarterly is our compounding period. How long? It says is how long means the time, we don't know the time. And 12,400 is the final amount. So let's look at that one. Here, A is equal to P1 plus R over N raised to NT. Okay, so our final amount here is going to be 12,400 is equal to the principal 8,000. 1 plus 7% is the same as 0.07, and compounded quarterly is equal to 4. And then we don't know time, so we're just going to say 4 times the t. So we're going to use once again our knowledge here that we have to simplify this one first. So simplifying it, this is on this side, you're going to still have the same 12,400. This is going to be 8,000. And once you have used your calculator to simplify this one, this should give you 1.0175 raised to 4t. Again, then we're going to divide both sides again by 8,000. It's going to give you 8,000. That's going to give you 1. So what is left on this side is just going to be your 1.0175 raised to 40. Okay, so on this side, I'm going to put it that way. So that's going to give you 124 divided by 80 is going to give you 1.55. Okay. Now we need the help of logarithms in here. So we're going to multiply both sides with logarithms. Okay. So in this side, you have your logarithm of 1.55, and on the other side is you're going to have the logarithms of 1.0175 raised to 40. Okay, so still here the same is going to be 1.55, but this time we're going to put this one in front. 40, the logarithms of 1.0175. Okay, then we're going to divide both sides again by the same logarithm of 1.0175 to isolate 40. So this is going to be cancelled out. What is left now is going to just be this one, the logarithms of 1.55 all over the logarithms of 1.0175. Okay, so if we're going to use our calculator here, this should give us this amount. So 40 is going to give you this amount, 25. Okay, I'm going to write the whole numbers once again, okay? 16, 32, and 79. And we're going to divide both sides by 4 in order to isolate t in here. So that should give us around 6.315408196. Okay, so this is going to be your 6 years. And if I'm going to multiply this by 12, that's going to give me the number of months, which is around 3 months. Okay, so if you're going to answer the question above, so it says that it will take 6 years and 3 months. So this is your final answer here. At 3% annual interest compounded monthly, how long will it take to double your money? Okay, so what is given here is the rate, which is 3%, which is equal to 0.03. Compounded monthly is going to be 12, and time is we don't know, but a principal is just its principal. So the question is asking you how long will it take to double your money? So it means to say that our A here is equal to 2 times the principal. Okay? So let's put that one. A is equal to P1 plus R over N raised to NT. So here we have 2P is equal to P1 plus 0.03 all over 12 raised to 12T. Okay? We don't know the time. So let's simplify everything. So continue here is 2P. P, if you're going to simplify all of this should give you 1.0025 and it's raised to 12T. Okay, there you go. So let's see. Now we're going to divide both sides with the principal. So we isolate this one. So on the left side, you have 2, and in here you only have 1.0025 raised to 12T. Okay, so in these cases already, we know that we need to have logarithms. So we're going to use logarithms again in here. Here, the logarithms. Here is logarithms. Therefore, what we have here on the left-hand side is going to be the logarithms of 2 divided by the logarithms of 1.0025 raised to 12T. Okay, continuing the process, it's going to give you this one. Put it on the very beginning. 12T, the logarithms of 1.0025. Okay, so we're going to divide again by logarithms of 1.0025. That is to isolate 12T all by itself. Okay, so if you're going to simplify that now, all you can see now is 12T is equal to this part, which is the logarithms of 2 divided by the logarithms of 1.0025, and this is going to give you around 277.605 3016. Now we're going to find the time, so we have to divide it again by 12 to isolate t. So here 12, it means t here now is going to give you around 23.1337 7513. So that's gonna around 23 years. Multiply this whole thing with 12, and that's gonna give you around 23 years and 1 month. Okay, so this is the final answer, 23 years and 1 month to make your principal double. So to summarize our lesson for today, we talk about compound interest. Okay. Okay, our formula, the first one is going to be P1 plus R over N raised to NT. And the second one is the compounding continuous compounding formula, which is P E raised to R T. Okay, so I hope you're going to remember all of these things, and thank you so much for watching.